the other. Now, your textbook or some notes online or some videos you watch may give you a different strategy. There are different strategies that will work. Some are better than others. The one I'm going to give you is the best one, obviously. So if you have x going to infinity or x going to negative infinity, this really only works for these two types of limits. The idea is that you want to somehow factor out the behavior at infinity, right? So you want to factor out the largest or the fastest growing pieces at infinity. And so what I mean by that is, so we are going to say, then factor out I'm putting this in quotes, highest power. I'm putting it in quotes because we won't always have polynomials, and we'll see how to modify the strategy for non-polynomials. But for a lot of times, we will have polynomials. Factor out the highest power of numerator and denominator separately. Or another popular strategy is, or factor out highest power of denominator from everything. Now, I'm already talking about numerator and denominator, so already I'm actually assuming that the expression you have is a fraction. So if we don't have a fraction, we also have to modify our strategy, right? And let's talk about horizontal asymptotes. The idea with the strategy, it sounds like I'm kind of just pulling the strategy out from nowhere, but the idea is you want to be able to exploit the limit we just went over, that very special limit that all of the reciprocals go to 0 at infinity. And the way you algebraically end up exploiting that is by factoring out highest powers, because then each term in the expression will end up being a reciprocal. And we'll see how that actually works in practice in just a second. Now, horizontal asymptotes. What is a horizontal asymptote? A friend just asked you what is a horizontal asymptote, and you got to explain to your friend what a horizontal asymptote is. So you're gonna say, well, it's like, and then you're gonna say something after that. Or it's basically, or it's essentially, right? You're gonna get all those weasel words out of the way first, and then you're actually gonna explain to your friend what a horizontal asymptote is. A value of y that the function can't be. Caleb, do you agree with that?
Yeah.
Yes?
I do.
Yeah,
I do.
Thomas? You're muted, Thomas. That's gonna be like the phrase on 2020's tombstone, right? You're muted.
I think it is. It's the line that the function or curve will approach but never hit.
Okay. So if we have like a line here, so if I have like a line, so a line that a function touches or approaches but never touches. Okay. So we'll adjust that in a second. All right, so in this definition, L is a finite number, right? Just to be clear here. So what is the definition of a horizontal asymptote? If, again, this is calculus, right? So everything we define in calculus is defined in terms of limits. So if either the limit as x goes to infinity of f equals L, or the limit as x goes to negative infinity of f equals L, then we say that y equals L is a horizontal asymptote. Oh, I ran out of room. Okay, so we're gonna put say over here, delete that, and all this. So again, notice that we are defining this in terms of limits. So when I ask you, how do you find horizontal asymptotes? What is a horizontal asymptote? It's always defined in terms of limits. Now let's address what some students said about what they thought a horizontal asymptote was. And Ashika also has a question. Can't a graph go through a horizontal asymptote, though, on some occasions? Okay, so let's discuss this. So first, I want to ask a bonus question. How many horizontal asymptotes can a function have? So last lecture, I asked how many vertical asymptotes can a function have? And a few of you came up with the correct answer, which was it can have infinitely many, right? For instance, y equals tangent of x has infinitely many vertical asymptotes. How many horizontal asymptotes can a function have? Is Jessica the only one with an opinion? Do we all agree? All right, so let's do our classic poll to make sure everyone's here. Now, is this going to be the classic everyone gets it wrong or everyone gets it right? What do you think, Mohammed? What do you think is going to happen here?
I think everyone is gonna get it wrong.
Wrong? Do you like it when everyone gets it wrong?
Yeah.
Yeah? You think that's funny?
Basically gets a meme. It's just like, oh yeah, it's calculus. Whatever the poll is gonna be, the majority is gonna get it wrong.
So the question will be, how many horizontal asymptotes can a function have? And I'm going to write down what's in the chat. So I'm going to say up to 2, up to 1, infinitely many, none, not sure, or none of the above, not sure. There we go. Then we save. We do the poll. All right, here we go. Let's see. Does the meme survive? If polls were great, I'd be failing this class. Well, you and 80% of the class, right? All right, about 10 more people. Come on, let's get that. Let's get everyone voting. We like to see everyone's awake. Breakfast is over now. All right, your pancakes are done. Your burrito, whatever you were eating. All right, so in 1 minute, 94% of the class voted. And as per usual, no, actually, this is the correct answer. So up to 2 is the correct answer. So how can it have up to 2? Well, if we just look at the definition, I can have an asymptote occurring because I get, say, the limit as x goes to infinity. I can have the limit as x goes to infinity of the function, say, equals 4, right? But then I can have the limit as x goes to negative infinity of the function equals, say, 2. And now I have 2 separate asymptotes, right? Because this definition tells you that if either of these limits is equal to L, then that line is a horizontal asymptote. But there's no reason they have to be the same number, right? So you can have up to 2. Let's actually draw an example of these. All right. So let's look at, say, no horizontal asymptotes. Can I zoom in? There we go. So let's look at no horizontal asymptotes, one horizontal asymptote, two horizontal asymptotes, and then I'm going to look at a fun case. So 0 horizontal asymptotes, for instance, I can just have a polynomial. So polynomials don't have any asymptotes. So I can just have something like this, right? So as x goes to infinity, in this particular case, x goes to infinity, I get infinity. X goes to negative infinity, I get negative infinity. There's no horizontal asymptotes in either direction. Let's look at one horizontal asymptote. All right, and then I'll do 2 down here, 1, 2. So I can have something that looks like this. So let's say, all right, so as x goes to infinity, I get whatever the value of on that line is, right? So it approaches that line, so it's horizontal asymptote, but towards the left, I don't get anything. And then on two horizontal asymptotes, maybe I can get something like this. All right, let me stop sharing the poll just in case it's covering something up. But now let's look at a fun case. Now there was a specific issue of, is an asymptote something that a line, that a graph never touches? So here's another question. Can a graph cross a horizontal asymptote? We have some no's, we have some yeses. Well, yes, of course. So if there's a jump, now let's say the function's continuous. Function is continuous, so it can't have any jumps. I actually haven't talked about continuity, so I can't tell you, so I can't use that word. Let's say the function has no jumps. A function can very much cross its horizontal asymptote. In fact, how many times can a function cross a horizontal asymptote? So let's see. So here's an example of a function crossing horizontal asymptote once. Right? Why is this still horizontal asymptote? Because let's say this is y equals 3 with this line. The limit as x goes to infinity of this function is still 3, right? What happens over on the left doesn't matter. So all that is immaterial. All that happens is what happens as x goes to infinity. Can it cross twice? Sure. 1, 2, there we go. Can it cross 3 times? 1, 2, 3. In fact, it can actually cross infinitely many times. Right? You can have it cross as many times as you would like, but not only just as many finite times as you want, infinite many. So let's imagine a function like this that crosses it, and then the graph actually just oscillates around the horizontal asymptote, something like that. Right? So the function goes above the horizontal asymptote, comes back down, but not quite as much, then goes back up, but not quite as much, goes down, up. It keeps on oscillating around the horizontal asymptote, but the oscillations themselves are getting smaller, right? You can almost think about it's like a damped oscillator if you've taken, say, physics before, right? So this would be an example of one horizontal asymptote, and the function actually crosses it infinite many times. So that idea that you had in pre-calculus of a line that a function approaches but never touches, that's complete nonsense. Okay. Now let's get down to business.